Okay, so this is uh the Grasshopper tutorial. So I think yesterday Sanya went through like the knobs and meshes and how to do stuff in Rhino. So like if you like for example like make a sphere here, for example, like let me set this to another layer and she did stuff like you try to merge a few spheres together, you arrange them together in Boolean union, and then things like if you contour it from the start and then you draw it contour outwards and you can get like contour lines and everything, right? I think that's one way you can do it in Rhino. And today I'll show you the basics of Grasshopper and how to do things that you would do in Rhino in Grasshopper as well. So whatever you can do in Grasshopper, you can do it as well in Rhino. It's just that it is something that is more tedious. So usually Grasshopper will help you for things like if you have many of the same commands to run. So you don't type uh like union and then boolean union all the time. So you can just like automate the process. Or you can use Grasshopper as a computational form finding tool for you as well. So that's the two benefits that it can give you. Yeah. So if you go into Rhino, if you're following along, you can just do whatever I do. I'm using Rhino 8, so it should be up to date with whatever you're using as well. So to open Grasshopper in the Rhino command tab here, just type in Grasshopper. Yeah. And then you'll come up with a small like rectangle in front if you haven't loaded it yet. But I already loaded it, so it will come out straight as a Grasshopper. If you minimize it, you go to the bottom left here, you can maximize it again. Okay. And what I like to do, right, for Grasshopper is you don't want to do stuff here and then close it and then check and then do stuff here and close and check. Just drag down from the top and just put it to the side. And then if your viewport is the original viewport where you have something like split vertical, wrong shit, close view. If your viewport looks something like this, what you can do is choose one of these. Let's say I choose this one. I want to close viewport. So you type that into the command line and you press enter. That will close this viewport. Then you can extend this one all the way down and bring this towards the center. And now you have more space on the left side of the screen to look at Rhino at the same time as the Grasshopper. And this will be very useful, so you don't have to keep switching back and forth. Okay. So, okay, let's get started with some basics of Grasshopper. So, and not even a Grasshopper, okay, let's have some basics of computational modeling. Okay. So when you do modeling, there's the first thing you should think about also is what plane you're drawing on. Because if you tell the computer to draw a rectangle, like you can draw a rectangle like this. So this is on the XY plane, but I can also draw a rectangle like this on the ZX plane, or I can draw a rectangle like this on the YZ plane. And it doesn't know which plane to draw it unless you tell it to. And these are just the default planes. You can also draw rectangles like a slant like this, or even a double angle slant like this. So all this depends on what plane you want the computer to work on, right? So for the sake of simplicity, let's keep it to the three world planes, which is the XY plane, the YZ plane, and the XZ plane. Okay, so let me turn all these back on. Okay, so a robot XY plane, very simple. It is the x-axis and the y-axis, right? The YZ plane is the y-axis and the z-axis. XZ is the same, z-axis and x-axis, right? And this component here is what draws for me. Let me take you through one at a time. A rectangle. And then it fills in the rectangle with a surface. And it places a word text in the middle of the rectangle. You don't need to know how to do this. This is just a visualization so that it's easier for you to understand what are these components. Okay. So now that we know these three planes, I'm going to talk more about the primitive objects in Grasshopper. So there's a few things you can have in Grasshopper. So these, if you go up to here, the parameters, these are geometry containers that you can access in Grasshopper. And these are primitive containers that you can access in Grasshopper. Okay. So containers are sort of like groups where if I say I have a line here, I have this curve here, and maybe I have another curve here, and another curve here, and all these. And I want to put all this into one group and work on all of them at the same time. So instead of like extrude one, extrude one, extrude one, what I want to do is extrude all of them at the same time. And how do I do that in Grasshopper is by referencing all of them into a container. So for example, now I have these are curves. So if I select all these curves and then I right click the curve component, I can set multiple curves. And this will reference in these curves in Rhino workspace into Grasshopper. So if you hover over the curve space now, you can see 4 locally defined values, and these are the referenced curves. And if you click on them, you'll highlight it in Rhino. I think by default, it will be a red color highlight, something like this maybe. Oops. Something like this. Yeah, it'll be a red color highlight or a red color display. I'm not very sure, but the one that I have is green color because that's more fun. Set it back to there. Okay. Yeah. So now we have 4 curves referenced into here. Okay. So that's one way to reference things. If you delete it in Rhino, it goes away in Grasshopper as well, because now there's no curve for it to reference. Right. And if you want to dereference something in Grasshopper, what you do is you right click and clear values. So now you go back to orange, you say that it failed to collect data because we didn't assign any data to it. And now it's an empty curve parameter again. Okay. So there's a lot of these different containers. There's like extrusions, you can have boxes, you can have meshes and everything. But not all of them are very useful to what we need to do. And some of them, there's a bit of overlap also. And even for primitives, these are data types. So things like Booleans. Booleans mean whether a true or false value. So like if you get a toggle, it just tells you, and if I pull out a panel, let me just show you this. It's just whether it's true or false. There's no value, it's just a 0 or 1, right? Yeah, so these are, under primitives, these are numerical data values. And under geometry, these are objects that you can reference. Okay. So just some simple orientation to Grasshopper interface, right? Anywhere on this entire workspace here, this is your workspace. And this arrow points towards, this compass here points towards where your things are currently at. So if like my nodes are currently here, it's gonna point towards there. If I get lost somewhere up in this space here, it's gonna point towards the bottom left, sorry. So I just keep scrolling to the bottom left and eventually I'll find it. Or you can just press this view entire document and you zoom into everything that you have, right? And one way to, if you don't know what you're actually looking for, or maybe you need to click on this, like, okay, for example, you say I need to create a lot of geometry containers. Instead of going in here, click geometry, going here, click geometry, going here, click geometry. What you can do as well is you either press spacebar or you double click the workspace, and now you can enter a search keyword. So if you just type in geometry, now you can have it will give you all the related nodes to related geometry. So if I just need a container, I just create one of this. And you can copy paste it if you want also. Right? Okay. Then so those are containers. And next we have primitive inputs. So primitive inputs are numerical value inputs. There are quite a few. So we have number sliders where you can set in a range of minimum number to a maximum number. And you can tell it how many decimal points you want it to give. So you can even tell it to be integers only. So if I set this to like 12, you can see it only gives me whole numbers. Or if I set it back to a rounding with a decimal place, now I have all the intermediary decimal places between 0 and 12, right? So that's one way. Another way is what I showed you just now, a Boolean toggle, but this only gives you true and false. So Boolean toggles and buttons, they will only give you true and false data. True, false. This one also, true, false. Yeah. So these are the Boolean inputs. Okay. And another set of number inputs is a control knob. Control knob works similarly to slider, that you can slide it by in a circle. Digit scroller as well, similar to slider, but instead of left and right, you just scroll up and down. And there's no limits for digit slider. You can set it to any number you want. So I can set it to like that, and it'll come out the same number that I want it to be. Or I can have value lists and everything. These are more case specific kind of inputs. You don't need it all the time. Usually for my own use, I only use the sliders the most, and sliders are the most useful ones. So this one just tell you, for example, if I say if I want a value of 1 equals to 1, I can even give it a string of text to say. For example, I say text, it'll give you this is a sentence. Right? And if I create a panel, so panel is just like a display of whatever data is being shown. So if I connect it to the panel, 1 will give you 1. And if I change it to text, put a colon. Never mind, I guess doesn't give you that. Oh, if I put in double commas, yeah, you can get a string back out of it. So this is a text. Yep. Value lists are not the most useful. It's useful if you have a predefined number of values, because you don't want to go down the row and type 1, 2, 3, 4, 5, 6 all the way. It's only if you have like a few values that you know you're going to use. But most of the time, just use a slider. It's good enough for everything. All right, let me just put everything like this. Group it. So if you want to group stuff in Grasshopper, either right click, group, or another way is Control G to group. And you have a group where you can move around items. It'll tell you where items in a group are, so you won't get lost, and you can organize stuff. So if you right click your group, you can type in a label for your group as well. So you can just say numerical inputs. And now all this collection of numerical inputs, all this is Boolean inputs, right? I'm going to move this up to here. We're done with that now. Okay, so let me orient you to the rest of Grasshopper's workspace as well. So every label up here you see is either a plugin or a set of operations that Grasshopper has. So by default, Grasshopper has all these operations as well, up to somewhere around here, Kangaroo 2. Yeah. I think by default that's the original original components that Grasshopper has. Kangaroo 2 is the built-in physics simulation components. Rhino is just referencing things within Rhino. So you can reference in like model layers, you can reference in model objects, you can do drafting, you can include annotations, you can create like light spots for your rendering in Rhino as well. I never really tried this out. I found it easier to just do it in Rhino itself. But yeah, you don't necessarily have to use this tab. Next one is display. So these are your colors to set your objects to look. So for example, if I have, like, say, just create a box somewhere here, and then I reference this into a geo component, I hide it with a box. Right now, it's displaying as a white box because that's what I have it set in my document properties, right? But let's say I want to color it something else. So what can I do? I can create a custom preview, geometry into geometry, and then if I create a color swatch, this one, color palette swatch, and plug it into the material, you now overwrite whatever material this is. And if I send it to red, you turn red. I can set it to any other color as well, and any opacity as well, right? So this is one way you can separate your different components in Grasshopper so that you can visualize things easier. But this should no means be a final production. This is just for visualization. Okay, and this doesn't set the color of the object as well. It is just a display. So back in Rhino, your object is still if I delete all this, your object is still this original color that you set according to your layer. Right? Let me delete all this. All right. Okay, and the next one is transform. So transform is a set of operations you can do to your shapes. So you can scale the shape, you can shear the shape, you can orient it, you project the shapes. You can do arrays, like linear arrays, stuff like in Rhino, for example, I say I have a box here again, like this. If I array linear, which means to put things in a line according to how many numbers I want them to be. So I would say I want 5 numbers of boxes. You guys say first reference point, second reference point, let's say I drag it over to here. Now I have 5 boxes in a line. Exact same thing that what linear array does. Box array does it in a box, curve array does it in a curve, polar array does it in a circle. So it's all the same. Sorry, if I'm going too fast, please tell me. And open the Zoom on the other screen. Okay, please tell me if I'm going too fast. Fine, I understand this is the first time hearing about Grasshopper. Okay, so Euclidean, you can mirror, move, all these. Everything in Grasshopper is situational. You don't have to use everything, and you might not use everything, but just use the components that you are comfortable using, or the components that you know how to use. And then there's a million and one ways to get to where you want to go. So there's no right or wrong way. It's just optimal or less optimal way. That's all. Yeah. And then morphing, where you can twist boxes, you can twist geometries and everything. You can deform geometries and stuff like utility. These are like, imagine in Rhino you have groups. You can do the same thing in Grasshopper as well. You can group items together, and you can ungroup items at the same time. Next one, we have intersections. Intersections might be useful, might not be useful. So this just computes the intersections between whatever they tell you. So for example, brep, line. So brep and then one, like the spacing, line and then line, means it computes the intersection for brep and a line. And if you hover over any of these components, they will also tell you a short description of what it does. For example, like contour X, it creates a set of brep or mesh contours, right? I'll go into what brep means later, so don't worry. For physical as well, same thing. It computes the intersection between whatever it is. Clash does analysis on a set of shapes. So it doesn't care what type of object it is. It just return you whatever is the collision point. Yeah. Region does trimming and splitting. So the same in Rhino, like how if, for example, I have, like I say I have this box over here, and then I want to trim it with this line. So if I select the box and I hit trim, if I select the line and I hit trim, if I trim away this box, now this box loses this bottom part here. It does the exact same thing in Grasshopper, right? So like I say, whatever you can do in Rhino, you can do in Grasshopper, and vice versa. And then shapes, you have all these. You can do your Boolean differences, Boolean unions. You can union curve regions as well. And you can union and split meshes as well, right? And in meshes is where you work with a mesh. Yeah. So there's a lot of components. You won't, like I said, you won't have to go through all of them. Just, if you want to know more about what they do, you can always hover over what they do, and they'll tell you a short description. Same for utility. Utility is like things like to analyze or like to work on a specific mesh, right? Same for surfaces. I won't go through all of them. Uh, yeah, and same for curves as well. So there's a lot of components, but a lot of them do similar things, but at the same time, you won't have to use all of them, right? Vectors as well. So vectors can compute fields like magnetic fields, electric fields. You can create point grids. So you can randomly populate a geometry with points. So for example, if I have let's say I have a sphere, and then I reference this sphere into geometry, and I say I want to populate this sphere. Yeah, I want to populate this sphere with grid geometry, and I just plug that in. And now if I hide away this sphere, we have points randomly scattered onto the surface of the sphere, right? Yeah, and we clear this out. Okay. Okay. Yeah, and now we have planes. So these are operations you can do to a plane. So instead of just creating a static plane or so, you can do operations to the plane. So you can create a plane from an origin, a normal and all that, or you can adjust the normal direction of the plane. You can twist the plane, you can rotate the plane and everything. And yeah. So and these are points, how to construct a point, operations you can do to a point. You can search for the closest point to a point within a group of points. You can measure distances between points, and you can deconstruct the point back into its X, Y, and Z component. And you also have vectors. Right? So vectors are uh it's a value of it has a magnitude and has a direction. So for example, if I say vector X, Y, Z, now it's giving me a vector of 0, 0, 0, right? Which means that this vector doesn't travel anywhere. It has no length, it has no direction. If I say I have a vector or let me create a vector real quick. Let's say I have a vector that points in this direction like this. And now this vector is reading out 8.0, 8.6, and then 0. So that's a vector of if I can't display the vectors. Yeah, vectors are no display, but there's a vector in this top right direction this way, right? Yeah. And sets are quite important as well. So these are data manipulation tools where you manipulate, instead of manipulating objects like these, you're manipulating numerical values and you're manipulating data sets, right? So a list of values or like a group of values and stuff. And this is math, the math tab. So you have a lot of domains. You can construct mathematical matrices. You have logical operators where you have like AND gates, NOT gates, all this. Or you can do mathematical operations where you can like add, multiply, you can test for equality, larger than, smaller than, all of that, right? These are more math operations you can do. You can do Python or C# scripting, or you can do VB scripting also. You have all these other components, right? So I think all this is a lot to take in all at once. So don't be too intimidated. This is just whatever is available in Grasshopper. This is like me showing you the entire command like line of Rhino and then telling you that, oh, it's actually quite simple. And it is like, because in Rhino, most of the time you won't use everything. You just draw like lines and boxes and stuff. Same thing in Grasshopper. You won't use all of this. You probably just work with like a few select tools, and then now and then you try a different tool to fit your use case better. Yeah. Okay, so let's go into what all these are. So these are containers of points, curves, lines, surfaces, B-reps, meshes, and geometries. And I think these are the more common object containers, object types that you'll be working with. I don't really see anyone working much with like point clouds or subdivisions. I think those are very specific use cases. Yeah, I don't think we will work much with like you won't need containers for center marks or dimensions or anything as well. Those are extremely specific, right? So okay, let's get started with points. So everything in computational modeling is computed from, okay, not everything lah, but to simplify it, a lot of things are computed from a set of points, and they're all determined by a set of functions, right? So what is a point in Grasshopper, or what is a point in Rhino? So it is a set of three values. So if I could go to point, construct point, we create this component here. So it's asking what a component in Grasshopper does is that there's an input side and there's an output side. So input side, for example, for this component, construct point, it says construct a point from X, Y, and Z coordinates. So it's quite simple. You give it an X coordinate or Y coordinate and a Z coordinate, and give it a point corresponding to that coordinate. So for example, if I go back to the Rhino workspace and I go to isometric view, right? Now I have a point at here. Okay, let me call up a panel so it's easier for everyone to see. If I put into here, so what a panel does is it reads out the data that's contained within an output, right? So now I have 0, 0, 0. My point is at 0, 0, 0. And say I create a number slider. And if you want to create a number slider quickly, you don't need to type slider and then double click and then change all your values. That's quite slow. If you know what's your range you want to do already, you just double click. You type, for example, I want a range of say 0 to 15, type 0, dot, dot, 15. And if I say I want to specify it to one decimal point, I'll say 15.0, and I just press enter. So that will create me a slider from 0 to 15.0 and accuracy of one decimal point, right? Same thing, I can do 0 to 10, and I say I want this to be whole numbers. So now I have 0 to 10, and they're only whole numbers, right? Yeah. But no need to know all the shortcuts for now. It's just quality of life stuff to know, right? You can completely do this the old way of going input, number slider, double click, and then change all this yourself. So I say 15, and I say I want it to be one decimal point. It gives me the exact same slider, right? So don't have to worry. Okay, let's say I create 3 of these, one for each X, Y, and Z. And I plug this in, I plug this in, I plug this in, right? And now I can control the placement of this point. So now everything I'm creating within Grasshopper itself, there's nothing that I'm referencing in Rhino. If I select everything in the viewport, there's nothing I can select because nothing is being referenced. All this is being created, right? So containers are good for helping you to reference in items or containing a set of items. For example, if I have, I'll show you later, but if I have maybe like, I bring over this point container and I have many, many points that I'm creating. I can put them all into the same container by holding down Shift and dragging all of them into this container. So now within this container, I have 4 points instead of just each of these individual points, right? And if I want to remove from this, okay, so okay. That's a lot. But if I want to put a point into this container, I drag and click into here. If you try to drag and click in the next one, you realize that the first one will disconnect. Because by default, you can only connect one thing into a component at a time. So how to get about this is you hold down Shift, and then when you hold down Shift, you see this green arrow at my cursor, and the plus sign comes out as well. So if you hold down Shift, you drag, click it in. Now you see it creates 2 points because you are adding this point into there. And same thing for this, if I drag, click in, and drag, click in, while holding down Shift. If I want to remove something, I hold down Control and drag it the same way. So now if I remove this, if I drag this, means I remove this. If I drag this third one, I'll remove this third one. Right? So that's one way. Okay, now back to the point. So if I have this point over here, and I say, okay, my y coordinate, I want it to be, let's say 5. My z coordinate, I want it to be 15. Now I have a point that is 0, 5, 15. And let's say the x, let's push it out as well. Let's make some weird number like 8.6. Okay. So in the model space now, I have this point floating up here, which is from here in the x direction, 8.6 mm out. In the y direction, it is 5 mm out. And in the z direction, it is 15 mm out. Right? So now this is x, this is a y, and this is z. And this reaches my point here. Right? So that's how that's one way to very primitively construct a point in Grasshopper. Okay? And if, for example, right now, okay, now I'll go into the next sort of concept, which is now we're only dealing with one point. But what if, let's say, we're dealing with like a whole set of points? So just for simplicity in Rhino, I'm just going to create a few points and scatter them everywhere. Maybe I'll pull some of them up and down also. Like that. So now in Rhino, I have these points all scattered around the model space, right? And if I get rid of this, you see I have 6 points in the Rhino model space now. If I reference them into here, set multiple points. Now I have 6 points referenced into right here, right? But this is where it gets a bit more important to understand. So for example, if I let me deconstruct these points. For example, yeah. So these are the x values of all of the points. These are the y values, and these are the z values. But why does it start with 0? And what is this bracket 0 bracket? And why is it all like 0, 1, 2, 3, 4, 5? How do I know which corresponds to what point? Right? So let me internalize data. So now I have these points saved in Grasshopper. So what is very important to understand with Grasshopper data sets is that if I have a set of points like this, if I have 6 set of points like this, let me pull this out like that. This is very important thing. Let me screenshot this and I'll bring this to the OneDrive and I paste it here. Okay, so this up here, this is called a list. So 0 is your list. It's list number 0. Right? Because computationally, everything starts with 0. It does not start with 1. So it's 0, 1, 2, 3. So this is item number 1, this item number 2, item number 3, item number 4. But because bit-wise, it always starts with a 0. So 0 is always the first item. Right? So like you say here, like I have 6 points, but if you let me change it to another color. I have 6 points, but it always starts with a 0. And even though I have 6 points, my last number is a 5, right? But that's fine, because that's just how computers count things. So so this is a set of lists and the items within the list, right? And if I go back to Grasshopper, if I see here, for example, now I'm extracting out the Z component of each point, and I'm getting these values instead. So let me bring this over back to OneNote as well. If you notice here, how would I know like for Grasshopper, what is being retained as what? So this is what you call a list data structure. So this is the order of the items in your list. For example, my points, they are within this order. And when I do anything to the points, it applies the component to these points in the order of the points. So for example, now I deconstruct the point into its component numbers. And like for example, you look at the 0 component, the Z component of the first point, it is 0, which is accurate to what we're seeing here. And the 13.62 is 13.62, -8, -8, 4.4 over here, -4, and so on. So it will always apply, the component will always operate on its input according to the list order and according to the list structure, right? So this is very important to know, because if you don't supply it an equal number of inputs for certain components, it will not apply it correctly. For example, if I have a set of 5 points, so point number 0, point number 1, point number 2, point number 3, point number 4. And say I want to do an operation to these points, but I only give the operation 3 instructions. So I only give it instruction 0, 1, and 2. It will get confused about what order to apply the instructions to these points. Because you can match 0 to 0, you can match 1 to 1, you can match 2 to 2. But what happened to 3 and 4? It doesn't know what to do. So to simplify things, it will just go back to 0. Okay. You just go back, you just apply the 0 instruction to the point, and for 4, it will apply the 0 instruction to the point, because there's no instruction number 3 and there's no instruction number 4. So this is very important, that you have to make sure your data sets are lined up. Okay. Let me delete this back. Okay, so let's go into a bit of simple geometry creation from Rhino and Grasshopper. For now, I'm just gonna do a half-half system where I do half of the operations in Rhino and then reference them in Grasshopper. All right. So let's start from points. Since I said that most of the things you can create in Grasshopper, you can create from a point. So in Rhino, let's create a set of points. For example, usually if you want to draw a curve in Rhino, you go control point curve, and then you draw a curve by clicking on the workspace to create points that constrain this curve. For example, I clicked over here now. So that point there is now constraining this curve. It doesn't want to deviate because these are NURB curves which originate from a set of points. Now I say I want to make another point down here to constrain it. Now I have this point here constraining the curve. Make this one up here, it's going to constrain the curve up there as well. And let's finish off over here. So now I have a 5-point curve where these are the control points which constrain this curve, right? Let's say I don't have a curve, I just have a set of points. So let's create a point at each of these control points over here. And now I'll delete away this curve. And now I have this set of points, right? And let's reference all these points into point. So let's say select everything and set multiple point. So if I have a set of points like this, and I want to create a NURBS curve with this set of points, I have it out here already. But what you can do, if you don't know what is the component that you need, and you just know that, okay, I need to make a curve and I need it to be from a set of points. What you can do is go into the curves tab or whatever tab. So if you want to make a surface, go into the surface tab. You want to make a mesh, go into the mesh tab. But for now, I want to make a curve. So I go into the curve tab, and I want to create a NURBS curve. And NURBS curves are splines. So you go into the splines component and you look for the component that best represents what you want to make. So let's say I want to make a NURBS curve. Oh, so that's very nice. There's a NURBS curve that says construct a NURBS curve from control points, which is exactly what I want to do. So I'll click this and place this in the Grasshopper workspace. Okay. And now if I okay, so now we talk about inputs and outputs just now, right? So what is he asking for? Now he has 3 inputs and 3 outputs. So asking for curve control points, it's asking for the curve degree, and asking for whether it's a periodic curve or not. So periodic curve, in layman terms, is kind of like whether you want the curve to be a closed or open curve, right? I'll show you in a bit. Degree of the curve is something that's specific to NURBS curve. It's a bit more technical. You can just leave this at the original one. Yeah. So vertices is the same as points. They mean the same thing. So if I want to put this, I want these points to constrain my NURBS curve. I'll put these points into the vertex. And then now you can see it creates this curve for me. And if I undo the delete of the curve, you can see that this curve that I drew previously now is being recreated in Grasshopper, but not from a curve, but from a set of points instead, right? So let's see what it's giving me. It's giving me the resulting dot curve. It's giving me the curve length and also the curve domain, right? Curve domain is a bit technical. You don't have to know it now, but I think this two is a bit more make more sense for the curve that you're getting. So if I want to use a curve, let's say I create a curve container. Where would I plug this into? I wouldn't plug into length because that's just a number. I will plug it into the resulting node curve because that's what I want to take out. So now if I click on curve, you can see it's highlighted in green, the curve that I want to work on, right? And you get a lot of things in Grasshopper that you want to clean up, right? And you don't want to see everything at once. They just want to see the last component. Just select everything, right click, and turn preview off. So now I don't see the points. I don't see this node curve. I only see this final curve, right? Well, let's turn it back on. Yeah. So that's one way you can make a curve. And let's say right now I want to turn this curve. I want to turn this curve into a polyline. How would I do that? One way is that from these points, I can, instead of creating a curve structure, I can create a polyline. So I plugged into there. But then you realize that, oh, why is it not following along this curve? Why is it so jagged? That's because we're working in points, and node curves don't necessarily pass through these points. But polyline component, what it does is that it will force it will force the line to pass through exactly all these points, and these points are where the polyline will kink at, right? I thought about the close and open, right? So periodic curve, right now it's false. If I turn this to true, you can see it tries to close itself. And because it closes itself, it will deform a bit. For polyline as well, let me turn this off so it's easier to see. For polyline, if I close the polyline as well, you can see it draws a line from the start to the end, right? Yeah. So that's how you can work with points to create curves in Grasshopper. And the next one, let's talk about points to surfaces. So these are still very one-dimensional or two-dimensional lines. Let's talk about something more three-dimensional. So I prepared this set of these points here. Just delete all this away. Okay. Yeah, I go back into perspective view. So I have this surface over here and this set of points. So this set of points is control points of this surface. If I turn on the points for the surface, you can see it kind of matches one-to-one all these points. I just extracted this point and put it over here, right? So let's say I don't have this surface, but I want to create a surface. So what can I do? I can select all these points that I plotted out in Rhino, and then I put them into this point container over here and set multiple points, right? And now I have all these points inside here. And now I want to make a surface from these points. So just like what we did with curves, we want to make a curve, we go into the curves tab, and then we find the appropriate component to use. Now we want to make a surface. So we go into the surfaces tab, and we find the appropriate component to use. So say I have a grid of points, a very nice grid of points, and I want to make a surface from this grid of points. So what can we do is we can go into all these tabs, and we look for the most appropriate component for this purpose, right? So for like see, we want to make a freeform surface because this is very like there's no real order to it once we go into the z-axis. And you can say surface from points. So now this creates a component called surface grid, which creates a NURB surface from a grid of points. So what are the inputs for this? The number of points in the u direction, and whether to interpolate the samples or not. For interpolate, you can just leave it as it is for now. You don't have to really understand that for now. So for grid of points, it just wants you to input the points that you want to work with. So if you connect this in here, it's still not giving me anything. And if we click the error message, it tells us that input parameter u failed to collect data. And what is input parameter u? Is this one, the number of points in the u direction. So if I go back to the top view, you can see that, okay, U direction, in terms of surfaces and meshes, they talk about U, V, and W direction. So U, V, W direction, you don't have to get worried about what it means. It's just a fancy way of saying the X direction of the surface, right? So for example, if my surface is, let me unhide this. If my surface is this, the U direction is just this direction here. And the V direction is just this direction over here. And if my surface is rotated, even though my x-axis is horizontal in the model space, but U, V, and W directions are local to the surface itself. So now my U direction is this diagonal over here, and my V direction is this diagonal over here, right? So this is the difference between world coordinate system and surface mapping coordinate system, right? Yeah. So let me hide away this bit again. And now we know that, okay, so my U direction is this direction over here. And how many points do we have here? We have 1, 2, 3, 4. So under number of points in U direction, I can just create a number slider with 4 number 4. And if you don't want to create a range, right, you can just type in a number. It gives you a number slider with that number already. Right. So for example, you want to take a number that's like 2 decimal place, 4.00. I'll create one and you create a number slider at 4.00. But I just need a number at 4. So I just type 4, press enter, and I have a number slider at 4. Now I plug this in, and now I have a surface like this of 16 points and 4 points in the U direction, right? Like it. And now it will try to fit this surface to the points that I have. And if I unhide this origin surface, it's the exact same thing because we are creating a NURB surface, right? So that's one way you can create surfaces. And now let's say I want to do this entirely within Grasshopper, right? So let's delete all this first and let's dereference all these points. So let's say I want to create a grid of points. So if I want to work with points, where would I go? I'll go back to the vectors tab. Okay, so vectors contain points, planes, and vectors, not just vectors. So I say, okay, I want to create a grid of points. Okay, I go into grid and I go into square. So I say I want to make a square grid. I create this one over here. And by default, you place it at the world 0, 0. So this is my grid of points. This bigger grid here is just telling you what plane it is. So for example, if I go back to here, right? I turn on this preview. If I turn on the preview of my XY planes, you can see it gives me a square grid, but it's not actually a square grid that you can work on. This is just a display to show you what plane you're going to be working in. For example, the YZ plane, now you have a plane in the YZ direction, right? Same thing for square grid, because it's giving me there's a default base plane where it's at world XY plane, and now it's just displaying for me which plane I'm going to be working in. But the actual square grid that we're working with is this smaller square grid inside here, right? So let's create a few sliders because it's asking for a few inputs. So we have 3 numerical inputs and 1 plain input, right? So let's create 3 sliders. Let's say size of grid cell, let's keep it small. So let's say 1 to 5.0. And I plug that into there. So now if I change the size of the grid cell, you can see it's starting to change as well. So now if I say this is 5 and we count, so 1, 2, 3, 4, 5. Each cell is now 5. My units are at millimeters. So each cell is now 5 millimeters big, right? And say, let's see what it's asking for, extend X and extend Y. So number of grid cells in the X direction and in the Y direction. For the default value is 5 and 5. Let's say I want 15 in the X direction and I want 10 in the Y direction. So have that and that. Connect 15 to the X, 10 to the Y. And now I have 15 cells in the X direction and 10 cells in the Y direction. Yeah, let me align all of this. Yeah. And you can play with this so you can make more, you can make less. But just keep it there. Now you can change the size, you can change the extent and everything. So this is one way of creating geometry in Grasshopper itself. and say, so now I have two outputs. And now you notice that the data structure looks very, very different. For example, normally it would look something like this, where I get, if I have a list of points, it tell me only the points I have. If I apply the panel to here, it just tell me the points I have. But what this is giving me is this grafted tree structure. So now instead of just being 0, I have 0, 0, 0, 0, 0, 1, 0, 0, 2, 0, 0, 3, 0, 0, 4, and so on, all the way until 0, 0, 15, right? So no need to be scared of what is it. Okay, let me just go back to the grid cell outline. I think that's a bit easier to look at because now we have 15 grids. So let me simplify this as well, so it looks easier on the eyes. So now I have list number 0, we have list number 1, list number 2, list number 3. And because all these are grafted, so now if you look at this, right, let me screenshot right there, go back to here. Right, enlarge it a bit. Okay, so what this means is that here, this is the list number. So this is list number 0, number 1, number 2. Same thing as what we're looking up here. So this is the list number 0, right? And it's telling me n equals to 10. And what does n mean? So within this list, within list number 0, I have 10 items. So I have item index number 0, index number 1, 2, 3, all the way down to 10, right? And if we look back into here, we see that here we have rectangle number 0 all the way to rectangle number 9. Sorry, not number 10. What am I talking about? 9. Right. And for sake of simplicity, let's go back to points. I'm just going to create a area component, and that will give me the return also the area centroids. So there's just a point in the center of all these squares, right? And now you can see all these points representing the centers of each of these squares. And now they're all in 15 different lists. Right? So it's very important to know your data set, your data structure. For example, now if I create a move component and I want to move these points vertically, if I plug this into here, and I say, for simplicity, let's give it let me get a 2 by 2 grid first. All right. So I have a 2 by 2 grid like this. I guess I'm going to turn off the square grid so it doesn't look so messy. But now I have a 2 by 2 grid and I'm moving in all these points. Let's say we want to move it in the vertical z direction. Okay, so I create a z vector and say I have 4 points, right? So thinking that, okay, I have 4 points. I want to move them all individually. Let me create 4 sliders. Let's say 0 to 15.0. And I create 4 of them. Right? I plug them all into here. I plug all these into the translate vector. Okay, this one, what I'm doing now, the process, don't have to worry too much about what all this means. This is just an example. Okay, that I want to apply a move component to my center points. And I have 4 points, so I think, okay, I make 4 instructions to give these 4 points. And I say I want to move this, but now I'm only moving 1. Why is 2 of them moving? Same thing, I'm moving these 2. Why is 2 of them moving? I'm moving this again. Now I have 6 points over here. If I move this, I have another set of these points. So it's a very weird structure. So if I click on the move component, you can see this is what is trying to apply to these 4 points. But that's not correct to what we want to do. Because our data structure right now is that we have list number 0 and list number 1. And we have 2 items in each of them, like this. But if we take a look at the data structure of our vector component, they're all in the same list. And they're all, and it's from 0, 1, 2, 3. So now Grasshopper gets very confused. Because, like I said before about having the same number of items and same number of instructions, 0 to 0, 1 to 1, 2 to 2. If you have any more items or any more instructions to it, for example, now we have more instructions than items, you're going to apply the instruction number 3 back to item number 0, and instruction number 4 back to item number 0, which is exactly what it's doing right now. Because now we have only 2 items, but 4 instructions. So it doesn't know what to do with instruction number 2 and instruction number 3. And it's giving back to all to these points, right? And even worse is that now we have 2 lists. So instead of just doing it to this list, it's also doing the same thing to this second list. And that's why we have this very weird point generated out here, right? So what you have to do is to be very careful about the way you work with your data structure. So for this case, it's very simple to simplify it. There's operators you can do to the data structure. So if you right click an input or an output, you get these set of operators to the data structure. So for example, now you can see 8.3, 8.8, 11, 13.4, right? If I right click this and I click reverse, you can see that the list order gets reversed. So now it's 13.4, 11, 8.8, 8.3. But that's not what we want to do. I'll just show you what it means first. So if we choose graphed, it will put all of these items into its own separate list. So now here, instead of having item number 0, item number 1, item number 2, and item number 3, and in all of them in list number 0, we have item number 0 in list number 0, item number 0 in list number 1, 0 in 2, 0 in 3, right? But the item stays the same. It's just the ordering and the data structure changes. And if I flatten it for now, because this is already a flat list means that everything is put into one list, into list number 0. So this is already a flattened list. So if I were to flatten it again, nothing was to happen. But if I look over here, this is a grafted list because we have items in list number 0 and list number 1. And if I were to flatten this list, now we put everything back into list number 0. So you have 0, 1, 2, 3. And if you look at the left side, now our points, we can control them individually again. Because now the data structure is the same, right? It doesn't matter which one you are making the same to. So you can, for now, we're making all of them flat so that our items match the instruction. But if we say we have this as a grafted list, right? And we can also do the same thing where instead of making our items match instruction, we can match our instruction to the items. So let's say we simplify it and let me change your plans. Let me flatten that and then simplify this. Yeah. So now we have list number 0, 1, 2, and 3. But here is only list 0. So what we can do is we can graph our instruction list as well. And because our instruction list and our data set list is the same again, so even though that now is a grafted data structure, but we can control them individually as well, right? So as long as it matches the data structure, then you're good, right? But this doesn't have to apply for everything. This only applies if you have specific instructions you want to give to each individual data point. But if you say, I want to move all of these points up by a factor of 7.4 and just leave it all in here, I just connect in 7.4 to this. And like I said about how if I have not enough instructions for my data set, you apply the instruction of number 0 back to all of them. So for example, where's my eraser? Let me delete all this. So if I have five items in my data set, only one instruction, it will just apply the instruction to all of the items in the data set, right? So for example, in this case, it's going to apply this 7.4 factor transform to all the items simultaneously, right? So this is a very small thing, but as in it look like it's like a very small thing to talk about, but it's very important when it comes to making sure your programs run smoothly and according to what you want. Okay. Yeah. And don't worry too much. This is when the time comes for you to work on it, you can ask us again. And now this is just a um introduction to what's about to come. Yeah. And okay, so this is how you can generate a square grid like that. Okay. So going to surface breadth mesh, I'm not gonna create one for each. I think it's the same process as creating a curve, creating a line, creating a surface. Go into the appropriate container. For example, I want to make a mesh and go into the mesh container. And then if we want to create a mesh, we don't go into analysis tab, because analysis is just you're gonna have existing mesh and then you analyze that mesh. Primitive is you construct a primitive mesh, but triangulation is where it's a bit more automated. For example, if I have let's say I have this set of points here, and I want to triangulate these into a mesh. One very simple way is just to use Delaunay mesh triangulation. So that this just tries to connect points with its neighbors. So it's called the Delaunay algorithm. It just connects points to its closest neighbors. And same for Delaunay edges. Edges just returns you the edges, so the connectivity of these points. But a mesh will return you the actual mesh. And if I press Ctrl M, you're gonna see the structure of the mesh as well. Right? So you're not going to try connect this point to this point because these are too far away. You just try connect it to its immediate neighbors. Right? You don't have to understand how it works, just know that it works. And these are the other components of all these things. Right. So that's your base introduction to inputs and containers and object types in Grasshopper. Right. So not sure if it's a lot, but please slow me down if it is, or like ask questions. Yeah, you don't have to be quiet. Okay. So I think now I'll just go into a few examples of like different Grasshopper scripts and what you can do with Grasshopper, and some useful plugins that y'all might use in the future. So you don't have to understand what is happening now. You just need to see what Grasshopper can do for you, or like you don't have to understand the individual components and understand how it works specifically, but just know what is the possibility, right? Because like I said, that everyone's project is going to be different. Everyone's Grasshopper script is going to be different. So when it comes to writing your own Grasshopper script, it's the way that you write it and it's the way that you want your output to be. So I think when the time comes for that, you be a lot of consulting uh on your individual scripts rather than like following any common tutorial kind of thing. There are a lot of good resources out there. I'll compile a list of resources as well. But when it comes to like specific problems, you might have to consult one-on-one to fix the problems. Yeah. Okay, let's go into some example files. So I created this file some time ago. What's it called? What's it called? Wait, where is it? Oh, it's an Reliance path generator. Okay, so this is a script that mimics FreeAuto's wet thread. So if I go for a short introduction, FreeAuto wet thread is like the idea of having wet strings and then you let them like stick to one another, and like imagine you take like wool thread, then you just wet them in water, then you place a couple threads together, and then you start to stick together and form and everything, right? Like it's kind of fibrous, kind of tectonic, right? Bundling and all this stuff. So this is a very simple simulation of that, written in Kangaroo, the Kangaroo plugin for Grasshopper. So this is the physics simulation. So we have a set of points, these are the input points. I've preset these points already. And what we do is that we interconnect all these points with one another, right? And this applies a thing where you divide all these lines into many, many points. Because if we talk about a rope is just a set of many, many small segments that are allowed to flex with one another. Because if we don't have all these small segments, you can imagine this as one solid metal beam. But if you talk about many, many small segments, you can think about this as one long bicycle chain instead, right? And so along all these points, we'll apply we'll apply a charge to all these points to attract them to one another. So according to how far they're away from each other. So these 2 points will attract each other, but more than these 2 points will attract each other because these are closer. Imagine them as all small magnets to one another, right? And we anchor down this component here, we anchor down all these starting points, right? So where we're starting from, we'll keep them as our anchor point. So we don't want them all to move. We only want this mass in the middle to move, right? So if we run the simulation, we reset it first, and then we run the simulation. You can see it starts to entwine and starts to bundle together. And my computer is very slow, but your computer should run this faster. Mine's an old computer. Yeah, let me just pause it over here. So now we have this. Oh my God, it's so slow. Okay, so now we have this bundle of threads that we started out from something very rigid and very straight, and now we simulated all of them as a wet thread. And we're only trying to simulate from 10 points of interest, but you can do as many points as you want. So this is a solver. So what a solver does is that it iterates this entire thing over and over until it settles into it converges into a solution. Right. So it doesn't necessarily have to converge. Some solutions will diverge as well, and it becomes very complex and very messy. But for this simulation, it manages to converge into a single solution, right? And so if you look at it in 2D in Rhino, these are all individual lines. And if you want to extract data or geometry from Grasshopper back into Rhino, what you can do is go to where the object is being stored. So for example, if I want to extract these lines, I'll go into where do I go to? I go into solver. No, I won't go to solver. I go into join, and whenever I click this one, if you click on join, you see, okay, these are selecting all the lines that I want to use now. I can right click and bake into whatever layer I want. So for example, right now, I have 2 layers in my Rhino file. I have the draw layer and the solid layer. So if I right click and bake it, I can bake it into, let's say this is a drawing, so I can bake it into a draw layer. I choose whether I want to group all these together. So I say I want to group it because it's too messy otherwise. And then I bake it into there. And now I have lines that I can manipulate in Rhino as well. So this is where you can have a hybrid Rhino Grasshopper workflow where you don't necessarily do everything in Grasshopper. You can do a part of it, bake it, and then continue the rest in Rhino. Because maybe like it's easier to do in Rhino or whatever. Or you're more proficient in Rhino. Right? So that's one way you can work on it. Say, and for these points, if I bake these points as well, so I can also bake the points. So I have these 10 points over here. And if I move these points in 3D, so now all these points are flat. And if I move these points around, and move this like that, and move that like that, maybe I'll don't need so big, so I'll make it smaller a bit. And I'll bump this down. Maybe I'll bump this closer or something. Right. So now what I do is I re-reference these points back in. So I clear values and I set multiple points. And now we have this 3D sort of like meshing intersection of everything. So when you want to reset a solver, okay, now it's like it looks disconnected, but it's just a hidden line. It joins to the reset button. So I just reset simulation and it goes back to the default state of just straight lines first. And okay, let me pull this one all the way down here, right? Now I want to simulate this instead. Instead of a 2D, and now I'm simulating a 3D wet thread experiment. And it worked exactly the same because there's nothing that constrains it to only being a 2D experiment, right? So this is a bit lame. So I'll turn this off first, make it bigger, and reset it, and then simulate it again. Yeah, let it do its thing. That's still quite lame actually. Let me put this, yeah. And let it finish simulating first. Let it converge into a solution. Okay, and now once it's done, we have this like web looking thing. And one good thing about uh Grasshopper is that there's a lot of plugins for it. So for example, now I want to make this into like a solid. Right now they're just lines. But if I want to make it into a solid, I can use this plugin called Dendro. And what this does, it can do uh three different operations. You can create a volume from a curve, from a mesh, or from a set of points. You can also, this is the volume to mesh, this is the export thing, so that's not really an operation now. But I can have three different inputs into a dendro volume. And this will just create a three-dimensional volume around these curves. So for example, like for now, I'm working with curves, right? So I can create a curve to volume. And we look at its inputs again. So we want input curves, input the radius of the curves, and we have a list of settings. So because this is a Dendro plugin, so in settings, we have to go back to the settings component. And this will vary from plugin to plugin, but you should always read the documentation for your plugin to understand how the plugin works. For this one, this is how it works, that you need to create a setting and plug it into the settings component. And size of voxels, I'll leave it, say 1. 0.1. Okay. Let's say I want my radius to be, let's say 2. And now if I plug in the curves to the curves component, we have this 3D volume now. And if I increase the radius of the curves, you see it gets larger as well, right? And if I then apply a smoothing component to this volume, turn off the preview and put this back into here. And if I increase the width of the smoothing, so I can set, maybe I want to do 10 iterations of the smoothing. So originally just 1, but if I smooth it more and more, you see it gets into more like a sticky kind of shape. I don't know the word to describe it, but I can change all these values as well. Say I want to change this to 0.9. And end of the day, if I want to commit to this shape, yeah, increase the number of iterations maybe. There you go. So I want to commit to this shape. Let's convert. Right now we're giving out a volume because that's what the plugin does. So I want to convert volume back into a mesh. I just use the volume to mesh component and I can bake this back out. So if I turn all this off, now I have this mesh here. It looks very rough because these settings are very rough right now. But you can refine the settings and it'll take longer to compute, but you look nicer. So for example, if I try to do a 0.1 adaptivity, then I try to bake this back out, it'll be a lot smoother, right? So this is one plugin that you can use to turn curves, points, or meshes that otherwise don't have a volume to itself into something with volume. Right? So this is a visualization or like a final production kind of tool, where this is your skeleton, and now you have the meat surrounding the skeleton, I guess. Yeah. So this is one example of how using different plugins combined together to create something that you want at the end. Yeah. And not just having I draw a point and then I draw a line and then I manually and I specify this point joins to that line, that point joins to that line. But this one is something that's more iterative and more generative. That I don't know what's my final form gonna be, but through this simulation, I create this form. Right? From the only thing being able to set is the number of points at the start and the placement of these points. Yep. And that's one way you can go about generative design in Grasshopper. Yeah, I know it's a lot. I'm sorry if it's a lot, but Grasshopper is very in-depth. You can do a lot of things. So you can do things like for example, right now, this one is like robotics. So I'm not sure if I have it here. You can even do things like let me see, do I have anything for it? Script, no. Mirror, no. Oh, I already not have anything. Um, oh, okay, I guess I don't have anything. But what you can do is you can create a lot of different kind of things with different plugins. So for example, like this plugin, it allows me to control ABB robotics within Grasshopper. So these are like very case specific kind of plugins. Or you can also have plugins like pufferfish, where they are very generic but very useful tool to supplement your vanilla Grasshopper tools. So for example, vanilla Grasshopper only has so many like meshing components, but with pufferfish, you can supplement a lot of these with a lot more advanced and a lot more useful tools. For example, you can voxelize, you can uh pipe meshes using just a curve. You can extrude meshes, you can weigh meshes, you can tween meshes, all this. And they have different additional components for all the stuff. So even curves in this, you can even work with numbers, you can work with planes, all these. And these are very like good vanilla plus add-ons to your Grasshopper, right? You can even do butterfly. Butterfly is a wind CFD analysis. You can also use Ladybug. Ladybug is like a climatic analysis. You can analyze like shade benefit, your view percentages. You can analyze like thermal shade and all this. And all these are also not just simulation, but they're also rooted in real world data. So you can import in weather data from online. Oh, I did a oopsie, but you can import in weather data and locational data. So you can import coordinates, you import in specific locations. You can import in Singapore's weather data, you can import in like America's weather data, all this, and you have a whole host of different tools available, right? Things like this one Tulibra, you can do things like wandering flocking, can do stigma G, all these. Yeah. I even think like anemone, where it's not necessarily a geometry centric plugin, but this is a workflow process centric plugin. So like I have here like loop ends and loop starts. Because Grasshopper doesn't allow looping, but with anemone you can create loops where you have a loop start and a loop end, and you can tell it how many iterations to run. And you just keep looping and looping. So for example, you can create like fractal patterns. You can create like your own simulations if you don't want to use kangaroo and stuff like that. Yeah. So there's a lot of different stuff you can try with. And you can even create your own objects. So for example, if I create like a curve divider, this is just a component of a few more Grasshopper components that does something I want. So I create two inputs and I create two outputs. And in a way, it's kind of like writing your own macros for Grasshopper, right? Or you can even write your own like plugins and stuff if you want to. Yeah. So I think that kind of wraps up for today's tutorial. It's uh it's a bit much to digest all at once, but I think the key takeaway from today is it's not really about this what's on screen right now, but it's about this previous one that I was showing, this original, this smaller file here, where we're just talking about um data sets, and we're talking about uh the primitives, so planes, points, curves, lines, different types of geometry in Grasshopper and different type of inputs in Grasshopper, and understanding how all of these play into one another. Where if, for example, like I say, I create a component, uh, say I want to interpolate. If it's asking for vertices, I cannot give it a surface to interpolate into a curve. I can't like just give it a, I can't even give it a rectangle to make into a thing. Let's say I want to make a interpolate a curve around these points of the rectangle. I can't just throw this into here and expect it into interpolate. Like it's going to return me an error because what it's asking for are points. They're not asking for a reference polyline instead. What you can do instead for this specific case is you can explode the polyline and get the points of the polyline. So now you have these points. If you throw these vertices into vertices, so it's asking for vertices, you got to give it vertices. And now we can have this interpolated curve around it. If we want it to be smooth, we can just turn on periodic curve. And now we have this circle, sort of a circle, which this rectangle is inscribed inside, right? So the idea that you need to look carefully at what are the inputs asking for and to give it accordingly what the inputs require in order to get the appropriate result that you want. Right. So Grasshopper is not really that confusing. You just need to listen to what it wants lah. Treat it as like a I don't know. Just treat Grasshopper like something insecure. So you gotta be very explicit in taking care of it. Right. Yeah. Some things will be smarter, but uh a prudent way to go about your scripting or go about grasshoppering is to be very intentional and very specific with your instructions. Yeah. I'll compile a list of like different plugins and different resources that you can go to visit. For example, there's this guy called Gediminas. This guy, Gediminas Cardelius. He's a very, very good computational design resource. He has a lot of tutorials and a lot of like not just Grasshopper, but also teaches you some stuff for Rhino as well. And uh like I said, all these tutorials, even like parametric files, I think they are great in the basics, but you shouldn't let what they're teaching you limit you to what you can do. Because these are specific to their use cases. Like they are the ones who want to make this chair in this design, but you shouldn't make your shape in this design just because that's the only tutorial you can find. I think when you look for tutorials, you should understand what the process is and the workflow behind the script rather than exactly following the script itself, right? I think that's why understanding all these individual components is very important, right? And I think that's about all for now. Uh, Thankfully for the coming exercise, I think y'all will only mostly work with Rhino. You can use Grasshopper if you want to get like you want to try it out, but you probably mostly work with Rhino for now, just to get started with things. Then exercise 4, it becomes more generative Grasshopper design, right? I think it shouldn't be that bad for now. I hope. Uh yeah. Anyone got any questions? If no questions, then I think that'll be all for today. Uh, if there's any questions later on, if you're trying, you can always message us still. And as usual, lah. I think if not, I'll stop recording here.